Okay, now for the second part of the video on trigonometry. So we're looking at number 6 here, and we can see our opposite is 105 millimeters, opposite the 14 degrees, and our m value is our hypotenuse. That's the longest side there, and that's usually opposite the right angle. Well, it is always opposite the right angle. So longest side, so it's another way of identifying the longest side or hypotenuse, is that it is opposite the angle, opposite the right angle. Okay, and this other one that is called the opposite is in fact opposite the given angle, the 14 degrees. Okay, so we have O here, 105, and our longest side hypotenuse, which is m. Alright, so we have O and H. O there, O here, and H here, our longest side. The only thing out of SOHCAHTOA that has O and H in it is SOH. O-H, S-O-H. So we can use sine is for S is for sine, and then we've got O and then H. Okay, so sine of the angle, which is 14 degrees, and then O, always do it in reading order again, so from here, read across and then down, so O, S-O-H. O is our 105, and H is hypotenuse, was our longest side, our M. Okay, so instead of H, we use M. Think of this here, it looks very much like this. Just have a look at this here. So S-O-H, S-O-H. Alright? And so what we need to do now, when the letter is at the bottom, you exchange that letter with the sine 14. You can swap it around. Now we don't have time to explain the reason why, but algebraically you've got something at the bottom there on the denominator, and you can exchange it with the whole thing that's on the other side. So we're moving sine 14 down underneath the 105, and the m goes back up where sine 14 was. And then you've got simply the m value. So now we can put 105 over sine 14 into the calculator, and you should end up with 434.02 millimeters. Now we can just check to see whether this indeed looks correct. Now the way it's drawn, it's probably not even drawn narrow enough, but this 14 degrees is a very, very tiny angle, so we're looking at a very long triangle. In fact, it should actually be even longer than this, because that 14 degrees is a very small angle. So we probably didn't draw it to scale. Now the thing is, what you have to realize, get used to this, in exams things are not drawn to scale. They're not drawn perfectly. The reason is they don't want you cheating and measuring the angle and getting the answer, or measuring the sides for instance and getting the answer, but they do it approximately. So you can kind of check to see whether it's correct or not, but just realize that really should have been drawn as a longer triangle but extended way out here with a very narrow degree. So we're really expecting our m value to be quite long. Okay, now it was 434, and yes, it's a lot longer than this little side over here. So we have done it correctly. Okay, now ignore this next little bit if you're not used to the magic triangle technique. I just wanted to show people in case you're used to that magic triangle and you prefer that method of doing things. Okay, so in this particular case, what have we been given? We've been given our hypotenuse. Okay, so our hypotenuse is over here. Think of just covering that up with your hand. I'll put the mouse pointer over that, so we no longer have our hypotenuse, because that was given to us, our m value. So all we have is our O and our S. Now notice that the O is higher than the S, and we're going to use divide in there. So our answer is going to be O, which is 105 over our sine of 14 degrees. So if you think of 114 for the O divided by sine 14. Alright, next bit over here, we will go to number 7, and we've got to label everything first. We've got our opposite, which is 20 centimeters opposite our angle. Now, this is a little bit different, this angle. Just realize that let's have a look over here. Why don't you use Pythagoras? We haven't been given an angle. Well, no, we haven't been given an angle, but there's a missing angle, and we're still trying to figure out the angle. Now, if that's the case, we're trying to figure out an angle. Over here, we're not trying to figure out an angle, so automatically we're trying to find a side. So that's Pythagoras, nothing in the middle, and we're trying to find a side. Over here, there's no angle in the middle, but we're still trying to figure out an angle. Alright, so we still stick with trigonometry, still stick with SOHCAHTOA, but we're going to use reverse trigonometry because we're not given the angle. Remember over here, this one here, sine C, we were not given C, so we had to use the reverse of sine -1, the inverse sine, because we're not given the angle C. We're trying to figure out our angle C. Over here, we're trying to figure out our angle P, so we're going to have to use our inverse, whatever it is, tan, SOHCAH or TOA. Let's first work out which one we're going to use. We've got our opposite the P is 20 centimeters, and our adjacent next to the P, so O and A. So the only one that we can use is TOA, T-O-A. Only one that has out of SOHCAHTOA is TOA that has O and A in it, T-O-A. So if we draw this up, write this up, tan of P equals O over O, which is 20, over A, which is 40. So you should really draw it up for the full working. You should write it up like this ideally, which is really following the same procedure. Tan of the angle equals the opposite over the adjacent that we've done up until now. However, we didn't know the angle, so instead of an angle with a number in there, we've actually written a letter in there instead. And in order to get that letter isolated by itself, we need to get rid of this tan, put it onto the other side, do the opposite on the other side, and it becomes tan -1. So as soon as I move that over to the other side and get rid of it, it becomes tan of -1 of all of that stuff, the entire stuff here, so 20 over 40. And then if you put that into your calculator, tan -1 bracket 20 over 40, you should end up getting 26.57 degrees. Does it look about right? Well, the smaller side over here is going to make the angle quite small, so it does look about correct. Small angle, nowhere near 90 degrees, right? So 90 degrees is way up there. It's a lot smaller. You could just look and see, well, does it look correct? Does it sound like it would be correct? And yes it is. Okay, final question here. Now, if you've read through how this works here, cables, we're trying to find out this distance over here, and we've got a tower over here. Right, so it's a rather complicated, but if I just see if I can make this a bit smaller. Okay, just to fit everything in so we can just see what we're doing here. Alright, so first of all, we're going to try and find out some of these unknown things. We want to work out the y value here, the height. Now, without really explaining this, to work out the y value, you would use this SAW thing here. We've got the opposite, and the hypotenuse here, and we've got 39 degrees. So in that triangle, that larger triangle, we could work out the y value, which is this one here. We've got our y value. Take a few extra decimal places. It's usually a good thing to take a few extra. Doesn't matter, just more than what you have at the end, because you lose a little bit of accuracy by the end when you get your final answer, and you want to take less decimal places in your final answer over here. So 7.52 couple of decimal places. You could take even one decimal place at the end if you want to, but just take a few extras just to begin with when you're doing the calculation, doing the prior steps in the calculation. Okay, alright, so we've got our y value. Now we're going to try and figure out our next thing here. We want to work out our b value here. So b is part of a smaller triangle. If we know the y value, and we're given that, and we've it's no longer an unknown, we've figured it out, the y value, and we've got 50 degrees, so we've got opposite in the small triangle here. We've got our opposite and our adjacent, so O and A. We'll use tan, so we're using tan here, and we can figure it out what that side is going to be. So we figured out our B side there to be 15.9475. Okay, and we also need to be able to work out the C value, and then we'll subtract. We'll do C minus B finally to be able to work out this distance here. But first, before we can do that, you've got to work out this entire base length all the way across to the end. Now you could actually use trigonometry at this point if you wanted to, because we know this. Could use Pythagoras at this point if you wanted to, because you've got this y value and you've got this long side, so you could go to square root of 30.2 squared minus the y value of 19, approximately 19 squared or whatever, or you put in a few extra decimal places when you're doing 19.0055 squared, and take the square root of all of that, and you would be able to work out that C. It's one way of doing it. Another way of doing it, C, is to use cos here. We've got the looking at the larger triangle, we've got hypotenuse 30.2. We've also got an angle in there, 39 degrees. And we're trying to figure out our adjacent, so we use ka, A and H as ka, and so we can figure out using cos here. Cos of the angle equals A over H, A being the, I've purposely not used A as any of these letters. Notice this is B and C. That's so you don't get confused with A, as we're going to call this our adjacent, our A all the way across from here to here. And of course the adjacent side all the way across becomes, in fact, it's been called C. So instead of A we use C there, and hypotenuse 30.2. Anyway, you can work out the C value there, and then you subtract them and get the final answer there. Get the final answer. Now let's try to make it so we can actually see it properly here. Okay, you can see it properly now. The answer's 15.9475, and whoops, sorry, no, it's back there. Okay, so 7.52 meters when we round it off.